In this presentation, I will be covering the inner workings of genetics in The Sims 2. I will explain its mechanics, quirks, and imperfections. I will also be comparing some aspects to other mainline games from the series. Apart from the original The Sims, as there are no genetics in the first game, Sims' offsprings are simply randomized there. The very first thing that I will be covering is the SimDNA. As the name suggests, it's the in-game equivalent of the real-life DNA. The information about Sims' eye color, hair color, skin tone, their dominant and recessive genes, it's all stored in here. Starting off with hair color, there are two dominant hair colors, black and brown, and two recessive ones, blonde and red. Each gene has their own unique ID. Sims can be homozygotes or heterozygotes. In the case of homozygotes, the same hair ID is written in both the dominant and recessive ID fields in SimDNA, while heterozygotes have different IDs written in the fields. When the baby's genetics are being determined, each parent randomly gives one of their hair genes. When the baby receives one dominant and one recessive hair color, they will be written in their respective ID fields and the dominant hair color will be visible. And when the baby receives two genes of the same type, either two dominant or two recessive, the game randomizes which to assign as the dominant one. The other one will be saved as recessive. The exact same logic is used for eye colors, with the dominant genes being brown, dark blue, and alien, while the recessive ones are green, light blue, and gray. Skin tones work differently to the other genes. Each sim has a skin tone ID that represents their complexion. They also have a skin tone range. This property is easily explained on an example. Let's take the previous Sims. When this pair of skin 2 and skin 4 has a baby, its skin tone range will be 2 to 4, and then its visible complexion will be randomly chosen from that range, meaning the baby might get tan, medium, or dark skin tone. The base max's skin tones are all seen as equal, though there are skin tones that are treated as somewhat dominant, those being alien, mannequin, and zombie skins. This is where I introduce custom genetics. Those are hair colors, eye colors, and skins outside the core ones, either maxes made or created by players. The somewhat dominant and custom skin tones sit outside the standard skin tone range, though there is a way to change that. What it brings is that those skin tones will always be dominant when paired with base complexions. For example, when a skin 4 sim has a child with a custom skin sim, the baby will always inherit the custom skin tone as the visible one. Same goes for the mannequin and zombie skins. And when two sims with different custom genes have a child, it is randomized which one will be expressed. Custom hair colors and custom eye colors are simply treated as dominant. The alien gene works a bit differently though, most likely because it's the only accessible one when playing the game without any cheats or mods. The way it works is that it will always be visible on a child of a homozygous alien skin sim. But when a sim is a heterozygote and forwards the alien gene to their offspring, the gene has a 50-50 chance of being expressed. This means that starting from the third generation of alien-related sims, the gene can be carried without being expressed, and then quotation marks randomly show up generations later. When creating sims in CAS, create a sim, they will always be homozygotes. The only way to have CAS-created sims with recessive genes is through generating them using the Make a Child feature. All the sims generated by the game will be homozygous, while the pre-made sims may have recessive genes. Another information stored in SimDNA are the dominant facial features. Those are sims' facial features that have higher likelihood of being passed down to their offspring. A sim can have multiple facial features set as dominant. For example, pollination technician number 9 Smith has 6 features regarded as dominant: brow, mouth, cheek, cheekbones, eyes, and ears. There are 8 possible dominant facial features: brow, eyes, ears, nose, cheekbones, cheek, mouth, and jaw. And here comes the first comparison to the third and fourth installments of the series. In The Sims 3 and 4, the kids are generated based on their parents' current physical traits, which means that if a sim dyes their hair a crazy color, the children can inherit that. Same goes for plastic surgery. If you have a sim in The Sims 3 go under a knife, their children will only be able to inherit those post-surgery traits. While in The Sims 2, all visual changes to Sims are simply cosmetic. All their genetic information is saved into SimDNA at birth, and all their offspring are created based on those values alone. Although the mechanics of trait inheritance are quite neat, the generation process is not so great. When the game has to generate anything, it uses what I'll be calling a random value hidden somewhere in the code. It can be used when generating townies or pets, adoptees, and kids born during gameplay. It's used a lot. It'll be easier to show in an example. I open up the game and adopt a child. That random value was just used to determine which face template, personality, and such are to be used when generating this kid. But here comes a problem. Said value resets with every new game session. Let's prove it. I close the game, open it up again, and adopt another child. As you can see, the kids have the exact same personality. We can repeat that process however many times we want, and all the same integer adopted kids will always have the same personality. Luckily, gender is always a 50-50 toss-up, and colors of Sims are random, at least for the non-childbirth generated Sims. So now let's show how it impacts having offspring. If you open up the game, have your Sims have 3 kids, close the game, open it up again, and have another set of 3, those 2 sets will be identical. Face templates, colors, personality, with the second baby always having the same personality as one of the parents and the same face as either of the parents too. The only things that are randomized are gender and interests. That is known as the sequence syndrome, or more commonly as the firstborn syndrome. So if you're not careful, you may end up with a family full of clones. There is a way to manipulate that randomness though. For example, if you open up Create a Sim and roll the pacifier, you are essentially using and changing that random value. Same goes for leaving the lot without saving. You can save the game before your Sim is to give birth, and after a baby has been generated, you can simply leave the lot without saving the game. Now when you go back and repeat the birth, the child will be different. You can do that however many times you feel like. There are also mods that can roll the value for you, so you don't have to trouble yourself with all that work. Concluding, randomness is not that great here. The process of creating Sims is much better in the later games. Although, on the bright side, you can abuse that system a little bit. For example, if you want your Sims to have identical twins. The general consensus is that every pair of Sims has a predestined sequence of children. Which, yes, they do, sorta kinda, like, for example, the third child of Daniel Pleasant and Nina Caliente will always look the same and have the same personality no matter the player or the computer. But the way people talked about it always sounded as if the game was to calculate every single possible combination between any 2 Sims, which would just be unreal. So here comes my theory, a Sim theory one might say, that those sequences are based on dominant facial features of parent Sims, and that those facial features determine the possible sequences. For that, I created 2 pairs of Sims with easily distinguishable features. Now, first experiment. I check the dominant facial features one pair already has, have them have a first sequence baby, save and leave. Change dominant facial features in SimPE, and have them have another first sequence baby and check if they got different features. And as you can see, even though they're both first sequence babies, they got different facial features from their parents. You can tell they're both same sequence babies as they have the exact same personality, something we proved a few slides ago. Second experiment, change dominant facial features of the second pair to the same features as the first pair. Have them have a first sequence baby, and check if the 2 babies created got same features from their parents. And as you can once again see, the traits that each daughter got from their parents are the same. Father's brows, cheekbones, jaws, and mouths, and mother's eyes, noses, and ears. So instead of there being prepared sequences for every possible pair of Sims, it's much more likely that there are set sequences for all possible dominant facial features configurations, or that there are some calculations made that take those features into an account. I also wanted to check if the game has some more complex system for recognizing which Sim is the mother and which is the father, But from my tests, it seems that simply the pregnant sim is assigned as the mother and the other sim is the father. I guess it's probably best that way. Sims can have between 25 to 35 personality points distributed between 5 trait categories: neatness, outgoingness, activeness, playfulness, and niceness. Sims created in CAS can only have 25 points, while those born in-game have the full range. And here comes more genetics. Below each personality trait, there is a blue line indicating the value of the genetic personality points. They will usually match up with the current values, but there are mechanics that change Sim's personality, like becoming a werewolf or being influenced by older Sims in the family. When two Sims have a child, those genetic values are being taken into account. Kids can inherit traits from their parents or have them randomized. For example, two Sims with 4 to 5 points in neatness are quite likely to have a child that is also somewhat neat, but there's still always a chance that the child will go into either of the extremes. Zodiac signs, on the other hand, are simply assigned to personalities. If a sim is born with 3 points neatness, outgoingness, and activeness, 7 points in playfulness, and 6 points in niceness, they will always be an Aquarius. The current season has no impact on the zodiac sign, which is how twins, even though born at the same time, usually have different zodiac signs. The only exception happens in plant sims. Kids always have the same personality as their parent, but they get assigned a random zodiac sign. As I have mentioned before, there is a way to make downloaded custom skin tones work in the same way as the standard Maxis skins. The only program needed for that is SimPE. First, let's start with the explanation of how the skin tone values actually work. Each skin tone has a decimal value assigned to it that's meant to describe how light or dark the given skin is. They go as followed. You might be wondering why I showed two ways of writing those values. It's because they're dependent on the separator that your computer uses. How to check which separator your PC is using? Simply open up the calculator on your computer and see what symbol it's using to describe decimal values. For me, it's the comma, so that's what I'll be using in this little tutorial. To show the process of genetizing custom skins, I downloaded Lilith Sim's Apple Pie Skin Blend skins. Let's say that I really like the tan skin, but I'd rather have it as a skin tone in between the S1 and S2. In order to do that, I need to open up the package file of the tan skin using SimPE. In the resource tree, I have to click Skin Tone XML, and now I click the only file that's available in the resource list. It opens up a window with lots of different variables and numbers, but the only position that interests us now is genetic DT single, as that's the variable of the decimal skin tone value. Now, since I want this skin to be in between S1 and S2, which have decimal values of 0.1 and 0.3 respectively, I can assign 0.2 as the value of this custom skin tone. Now, I also want to allow this skin to be used when generating townies, adoptees, and any other sim that there might be. For that, we need to look at the flags DTU integer line. But as you can see, there's something already written here. 0, X, a bunch of zeros, and then an 8. That means that this custom file is disabled from being generated on new sims. And since I want this skin to appear naturally in the wild, I have to change that last 8 into a 0. This will enable generating on new sims. Now that we've done it, we just need to check if it works. The fastest way is through CAS. As you can see, it works correctly. And now not only is this custom skin tone not dominant, but it partakes in the genetic lottery just as any other base game complexion. Job well done, in my opinion. This is all for the mechanical, logical part of the video. Next up, trivia and fun facts. If you ever played with the Rubin brothers, you may have noticed that their kids sometimes have elf ears when growing up that suddenly disappear when they become adults. That is because the brothers are using one of the broken face templates, the 25th. The other broken face template is the 21st. But what does it mean? It means that those templates are not properly linked between life stages. So when kids inherit those, Their features are linked to the other face templates until the proper ones become available again. The second face template is usually the go-to when the game tries to handle those missing links, although there are a few sims whose templates link to the 23rd and the 26th templates instead. And now something that's quite infamous in The Sims 2, the scary looking toddlers. Many a horror story have been told about two gorgeous sims having a wicked child, but fret not, it goes away. Usually, at least. And that is because unlike the later games, The Sims 2 doesn't babyfy the toddlers. In short, kids simply have all their adult features just squished and shrunk, which ends up looking somewhat uncanny. And now I'll quickly go over facts that are not really genetics related, but I thought that they would be still neat to include with the rest of the presentation. All babies in The Sims 2 look the same, much like the broken templates. They all link to the same face template. The only preset that has its own baby template is the alien one. And those baby templates can mix too, so you can have a baby with visible alien eyes and a standard sim nose, for example. There is a misconception that the game takes Sims' interest points into account when determining which hobby to set as their predestined one, while in reality they are calculated based solely on Sims' personality points. For example, a sim with the default Libra personality will always have predestined arts and crafts hobby. Pets can have dominant facial features too, along with dominant and recessive traits. That I stumbled upon myself when searching available dominant traits, and noticed that Bernard the Dalmatian has dominant brow, cheek, and cheekbones. There's also a mechanic that if you breed a big dog with a small dog, the offspring will always be identical to the mother. If you're interested to see the source material for the information compiled here, you can check those links. I also included them in the description for easy access. Any other information and images come from own gameplay, general knowledge, and experimenting with the game. But that's all from me. Have a nice day and have fun simming.